Good morning, everyone. Welcome to Coffee with Cluster1. This is Patricia here. And today we are super happy to have you here. If you haven't been with us before, what we're going to do is we're going to walk you through, we're going to have an introduction with Malo, and then Sohrab's going to speak on how to use Tensor2Tensor and Cluster1 to train models on OpenSLR. One of the things I encourage you to do is to please ask questions in the chat box, and we will answer them at the end of the show. But don't be shy. Let them come in, ask all sorts of questions, and then we'll go ahead and address them later. This Coffee with Cluster1 has been handcrafted for you for data scientists, developers, and deep learning aficionados. And so we're very excited to have the opportunity to speak with you and share with you today, and I hope you enjoy this show. Now please listen to Malo for a moment as he shares something about Cluster1.
Hi, my name is Malo. I'm a co-founder and product lead here at Cluster1. And before handing the floor over to Sohrab, we'll talk about Tensor2Tensor. I'll just give you a short presentation of what we do. So we were created with the vision of scaling AI and making AI developments at scale easier and more efficient for deep learning teams. And so we were founded in 2016, launched in 2017, and then raised our seed round in December 2017 with the Allen Institute for AI, which is a Paul Allen organization. And so what we aim to do is accelerate research in deep learning by enabling everybody to take advantage of scalability and distributed training and all sorts of tools and methods to make research faster. We aim at reducing the DevOps to zero so that deep learning scientists can focus on the modeling and the research and not the setup and the plumbing that's behind any deep learning experimentation. And we also want to make our platform infrastructure agnostic, meaning it can run on any cloud provider, on any machine, on-premise or hybrid, so that you can maximize the usage of your infrastructure and have the right machines that fit your need. And so the way the Cluster1 deep learning platform works is we can run any deep learning app. So that would be any framework, Jupyter notebooks, TensorBoard, or any tools you can imagine. And we give access to that through a variety of interfaces. So a CLI for scripting, an API to build things on top, and then a dashboard that's interactive and enables collaboration. And what we automate and take care of is all the OS parts. So managing Kubernetes, access control, providing tools to monitor and track all your jobs and your compute resources. And we make you independent from the underlying infrastructure, meaning a Cluster1 can run either on AWS, Google Cloud Platform, Azure, on-premise, etc., connect to any storage source and read from any code source. Sohrab will show a brief demo of the platform through his talk, and I'll just hand over the floor to him now.
Hello, everyone. Thank you for joining this webinar. And I'm going to share my screen right now with you. In today's agenda, I'll talk about Tensor2Tensor, distributed deep learning, and distributed Tensor2Tensor, how to run it on Cluster1. This webinar is a recap of last 3 webinars. In the first webinar, we talked about distributed deep learning. Second webinar, we talked about hyperparameter tuning. And last time, in the third webinar, Ryan Sapasi from Google Brain, he talked about Tensor2Tensor. So this webinar will be the mix of all those 3 webinars. I'll go briefly through, transformer model, the Librispeech dataset, Tensor2Tensor, and distributed deep learning. So, and if you want to go into more details, feel free go watch the last 3 webinars. They're more in depth. So just about Tensor2Tensor, it's a library of models, hyperparameter sets, and data sets that you can use, and it's available. So there are about 45 models there, and for each model, there's a hyperparameter sets that you can use, and also in the model and training components there that you can download and use. To remember, there are 3 really important scripts. If you know these 3, you can just start, running and train your models. Train the model from Tensor2Tensor. The first one is T2T-data-gen. It's for generating a data. T2T-trainer and T2T decoder. And I will show you a quick presentation how to use that. And there's a GitHub for Tensor2Tensor, and let me go there to show you what's in it. So if you go to Tensor2Tensor GitHub, if I scroll down, it's really simple. You can just do pip install Tensor2Tensor to install it, and then do T2T trainer to start training your models. There are lots of problems there. So as you can see here, image classification, language modeling, sentiment analysis. So for example, the one that I want to show today is the speech recognition one, the Librispeech. So I will go through Librispeech with you later in this presentation. So I talked about data generation. To create a data on using Tensor2Tensor, you have to do T2T-data-gen. You have to insert the problem, for example, MNIST, and then the directory that you want to save that data in, and the temporary file. And to train on that data, you have to you can just do T2T-trainer, you name the problem, you name the model. For example, this is a default model on T2T Shake. And I added a link about the Shake architecture later when we share our slide deck. You can go and read more about this model and the hyperparameter sets and, for example, the training set and eval set. So, but let me do a quick, show you how it works on my CLI. So, as I mentioned, there's T2T-data-gen. So I'm just running the code that I showed you right now. So if you just do T2T-data-gen, and this is the directory that I'm saving that data. I've already downloaded the data, so it will show that the folders are there, all the files are there. And but let me run it to show you how it's happening. It won't download it because I've already downloaded it in T2T_data. You can see that all the MNIST files are there. And the next thing that you do is to T2T trainer. So in T2T trainer, as I mentioned again, you just do T2T trainer, you name the problem, you name the data directory, the model that you want to use, and the hyperparameter sets, number of steps that you want to do, and you press enter. I ran this one briefly before. I think there are 2 or 3 checkpoints. So it will create a model, and then it will start training the model. So let's wait just for maybe for a few steps. Then I abort this job and go to the rest of the presentation. So yeah, there were 4 checkpoints there. And this is how easy it is to use Tensor2Tensor. You have to just create the data. Generate the data. And also, then later do T2T trainer to start training the model. So now it will show you in a few seconds. It will show you, okay, the number of steps, the loss function. So, but I won't wait here. We'll abort this job. But if I wait, definitely loss function will go down. There will be more steps. So that was about just a quick brief intro to Tensor2Tensor. It's a great library to use. Then I want to talk briefly about transformer model. This is the model that I will use. I use for training the Librispeech dataset. the one that I'm going to show you, which is part of the OpenSLR datasets. And the good thing about transformer model is its high accuracy and computational performance. Especially transformer model outperforms both RNN and CNN models when it was dealing with, for example, problems like language modeling and machine translation. And it's been developed by people in Google, and it's a novel model. And another good thing about transformer model is that it's computational performance. The reason is that RNN, as you know, is a sequential model, but and it makes it difficult to take advantage of GPU, because GPU run in parallel, so and GPUs excel at parallel. So because RNN is kind of sequential, so when you use transformer model, you will get a better performance. And also compared maybe to CNNs, there are less number of steps that you have to do, and it increases the performance as well. So, for example, let's give you an example of how transformer model works. Just let's look at this sentence saying that I arrive at the bank after crossing the river. So here bank, for example, if you want to translate it, maybe bank is show of a river or is a financial institute. But if you use transformer model, it applies a self-attention mechanism, which directly models relation between all words in a sentence, for example, in this sentence, regardless of where, regardless of their position. So, for example, when we give this sentence to the transformer model, it can quickly attend to the word river and find out what the bank, what's the meaning of the bank, and do the correct translation within a few steps or just a single step. So that's how it has really good performance. It doesn't have to go through all words. So with one, when it's see, for example, the river, it just knows this bank's mean show of a river. So this is self-attention mechanism. And these are two benchmarks of transformer model for example, the first one is for English-German translation quality. The second one is the English-French translation, the quality of that. So they're using Blue score system. And if you don't know about Blue, I added a link to Wikipedia. And if you just search for Blue, there are lots of articles about how you calculate this. This score, the Blue score. And as you can see, the transformer model, the performance outperforms RNN and CNNs. So for translation. And there are two articles that I really recommend you to read. It talks about transformer model and the attention. The attention is all you need. So if I go here, if I go to this one, this is an article that was written by people in Google Brain, Google Research, University of Toronto. It talks about attention, and also there's a blog from Google that talks about that I took those benchmarks from this blog. It talks about transformer model and attention. So feel free to go read this one to know more about attention model, and there's a cool animation here that shows how it works. So that was the transformer model. The reason I explained it briefly was because I trained the Librispeech model on the Librispeech dataset on the transformer model using Tensor2Tensor. The next one that I want to talk about is Librispeech. So Librispeech is a dataset for speech recognition, speech to text, and by default, Tensor2Tensor has these data sets. So as I showed it to you previously, you can download the Librispeech problem just by setting your problem to Librispeech when you do the data gen command. And there are two types of them: Librispeech, if you want to download the whole set, or just you want to download the smaller set, you can just do Librispeech clean. Actually, I want to introduce you to OpenSLR website as well if you are interested in speech data sets, etc. So you can go to OpenSLR and click on resources. There are a set of data sets there that you can download, and as you can see, Librispeech is there as well, these two, but there are lots of other data sets that you can download for speech and language, and if you're interested, you can use them. So that was a quick background about Librispeech, because again, in the model that I trained Librispeech. The next thing that I want to talk about is distributed deep learning, because, for example, the MNIST that I ran on my CLI, it was maybe single node, but what if you want to do distributed deep learning? So let's go quickly on what distributed deep learning is. So there are three reasons that you do distributed deep learning. The first one is train more models in parallel, which is experiment parallelism. Second one is train bigger models, which is model parallelism. And the last one is train faster, data parallelism. And I will go one by one with an example of how they work. For example, experiment parallelism, as I mentioned, you want to run multiple experiments concurrently and see, for example, which one has the best loss function. Maybe you are doing some hyperparameter tuning on a model. You have model 1, you change the configuration a little, then change it in model 3, and then you change it again, you create model 4. You run them, you train them, and you see at the loss functions over time or over a number of steps. And for example, you see, okay, model number 2, the green one, has the best loss function, and you select model number 2. So this is experiment parallelism. The second one was model parallelism. And the reason for model parallelism is your model is too big to fit in a GPU. Okay, so what do? For example, you have a neural net. It has multiple layers. For in this case, for example, 3 layers. You put the first layer on the first GPU, second layer on the second one, and the third layer on the third GPU, and then you split your model. And you do the forward and back probe. For example, when you do the forward probe, the GPU number 2 and 3 should wait for GPU number 1, and then GPU number 2 wait for GPU number 3 wait for GPU number 2. So this is forward probe, and vice versa, the same thing for the back probe. So this is model parallelism. Just remember, your model is too big. You don't have hardware that you can fit it in, and you have to split your model. And the last one was data parallelism. And data parallelism is to train your model faster. So your model fits on your hardware. For example, you have a GPU, it fits there, but you want to train it faster, do distributed training. So you use the same model and you put it on multiple, for example, GPUs. In this example, there are three GPUs, and you start training the same model on multiple GPUs. And these GPUs on the left side, they are, we call them worker replicas. They're workers. And this one, the right one is a parameter server. Usually parameter server, because it doesn't calculate, it doesn't do the compute, so it doesn't do the forward back probe. It doesn't have to be a GPU. You can even use CPU for this one. And the way that it works, is that, for example, GPU 1, 2, and 3, they calculate the gradients, the delta weight. They send the delta weight to the parameter server. Parameter server average them out and then send back the updated weights to the GPU 1 and 2 and 3 to their models, and then we do the training again and again. We calculate delta weight, sending it back to parameter server, and then we update the weights in the models. So there are two types of distributed, for example, if you use TensorFlow, distributed TensorFlow, one is synchronous training, the other one is asynchronous training. And the difference between the two is that when you do synchronous training, the parameter server waits for all workers to send the data weights to a parameter server. So parameter server weight gets all the data weights, the gradients, and then average them out, and then send the updated model to the workers, and then they start doing the computation. In the asynchronous training, parameter server doesn't have to wait for all of them, all the data weights that are coming from workers. So for example, only workers 0 and 1 can send the delta weight to parameter server. Parameter server calculates it and then sending it back, and then maybe later worker n and n-1 send the delta weight to parameter server, and then parameter server update the weights and send it back to the neural net, and then we do the computation. So this was the idea behind distributed, for example, TensorFlow, and now how it works on Tensor2Tensor. So if I go to documentations just quickly on Tensor2Tensor, and on the main page, if you go to main page, just search for distributed training, there's a link there, you can click on it and it will go to this page, and you can read more about distributed training, the parameters that you should pass. So the way it works is that the way that they define it in the Tensor2Tensor language. Synchronous training, when you have one master and many workers. So this is the master, these are the workers. So when there's only one master, it becomes synchronous when you use Tensor2Tensor. So one master, I think of that master as a parameter server, and the workers will do the compute. And in the case of asynchronous, there are independent workers synchronizing through parameter servers. So if you have more than, for example, one, there are multiple workers or multiple parameter servers, then this way it becomes asynchronous. And as I mentioned before, sorry, the parameter servers, you don't have to put them on GPUs. You can just use CPUs. They don't do the compute. But for workers, usually we put them on GPUs. So here, it's for Tensor2Tensor distributed. There's a file called, there's a JSON file called environment variable called tf_config, and it's really important that you define this tf config environment variable on both masters and parameter servers. And the reason for that is that because you define a cluster in that tf_config, and in that cluster you tell your instances, for example, if that instance that you put the code on, am I parameter server or am I master? How many masters or parameter servers are in my cluster? So by defining the PS and master, you define your cluster, how many PS master is there, what are the addresses, and by defining the cluster, they know how they can communicate with each other. I mean, what's the port that I should communicate, for example, on? What's the address? And then you pass them as an environment variable, and then you add a task to that instance. We're going to say, okay, your type is your master, and your task is task number 1. So to just better understand how does this cluster works, for example, in this case, there are 3 masters. This is the master cluster. This is a PS cluster, and there are different tasks. For example, task 0, 1, and 2. And on the PS cluster, there's task 0 and 1. And when you define this one, you create this cluster. So every instance is aware of the other instance and their addresses, and they can coordinate and collaborate with each other. And in the real world, the way that it works is that, for example, just think you have 5 machines. 3 of them are GPU machines. There's a GPU in them. And the last, and you have 2 machines that maybe they're only CPU machines. There's no GPU in them. You put tasks 0, 1, and 2 for the master cluster. So these are the masters. You put the task on machine number 1, 2, and 3. And then you have parameter server, you just put a task 0 on CPU 0 and 1. And because you define the cluster that tf config tf underscore config, now they are aware of how they communicate with each other. So that's how Tensor2Tensor distributed works. And now let me go to my code, the one that I used in on cluster 1 to train the Librispeech. Okay, so in my code, actually, let me start with the top part. I added 3 flags on the top. And the reason for that was that, I wanted to change the batch size and see, for example, which batch size is giving me the best performance, the best loss function. By default, for Librispeech, I think the batch size is about 6 million. For example, the default now I put it at 2 million, this number. And the reason I created this again was that I wanted to pass argument to my code and be able to tune the batch size to see which one is the best one. So here, as you can see, as I mentioned, you have to always define your dataset name, your problem, when you want to do, for example, data generation or train your model using T2T trainer. So Librispeech Cling was the one that I use. And if I go a little down, I talk about synchronous and asynchronous. I told you if there's only one, for example, a worker master, it becomes synchronous. But if there are more than that, it becomes asynchronous. So this is how I set that. And also, I talked about the tf underscore config. Then later, I just defined the tf config here, and I dumped the JSON file in it. So I tell, okay, I defined the cluster here using the tf underscore config. And the last important part that in your code that you want to use, when you code something in distributed Tensor is to define those flags. For example, which model you want to use. And, I talked briefly about transformer model. I use transformer models. I use transformer underscore Librispeech hyperparameter sets from Tensor2Tensor. And, I define the training steps, evaluation steps, the checkpoints, how many seconds should go that I save a checkpoint, and, the rest that, I talked about. So that's it. And this code is on cluster 1 GitHub. The description below that, I have to update it a little, but the code is available. You can go and see the code on cluster 1. So now let me show you how I ran this code on cluster 1. So if I go here, if I go to cluster 1, So I trained this model before on cluster 1. And if I go here, this is the one that I used, Sohrab OpenSLR test. And, you know, as you can see, I ran 19 jobs in this OpenSLR. And, you know, I did synchronous trainings with different batch sizes. I did asynchronous training with different configuration, for example, 8 GPUs on different instances, different batch sizes. So the way that you create a project on cluster 1 is very simple. You just click on all projects and then you add a project. When you click on add a project, we can connect to any, for example, GitHub or Git repository. So for example, here you have a GitHub repository. So I can click on GitHub repository, and I've already pushed, you know, all my code to my GitHub. So for example, this is my GitHub, MNIST is there, OpenSLR test is there. I won't add it because I've already, you know, done lots of tests on it, but you can just do add project, and the project will show up here. So for example, OpenSLR. And then when you go here, you can create a job. You can create a job. You just click on create job. And here you can select your, for example, your branch. There are 2 branches. So benchmark was the one that I was working on. I was doing a benchmark. And then you can select your Git commit. I select the latest one. I won't change the name. And here main dot, because I want to run main.py. So I just leave it at main.py. I go next. Here, I added a data set, and the data sets right now is on S3. So I can connect to S3 and, for example, select the Sohrab OpenSLR small. So you just add the data set. So the data set is there. Python version, it was Python 2. Here you can select different types of, you know, PyTorch, TensorFlow, and we can add, you know, any deep learning framework here. This is a hosted solution. In our enterprise, we can add that. So you can install packages here using pip and conda. For example, the name, I think the name of the requirements was requirements _ GPU, because I want to run it on GPUs. Here I go next. In this step, you can select how many hours you want to train your model. For example, let's put it 1 hour, and then you can select if you want to go single node, distributed, and here you can select your number of workers and number of parameter servers. So for example, let's do 2, 1, and let's do, for example, P3. So here you can select your instance type. So let me go and find the P3 2x large. Okay, P3 2x large, and then another P2 2x large. You know, CPU is enough, but, you know, let's just do GPU for now. Maybe 2 workers and 1 parameter service. Go next, and then this is optional. You just do create and start, and your job will start. Sorry, refresh the page. Your job will start. So morning forest is there. So it takes a little bit of time because we have to provision those servers, and we have to clone the code. I mean, we have to clone the code, and, you know, it's a huge code, so it takes 10 minutes. Maybe we clone the code 5 to 10 minutes. So I won't wait. But I ran, as I showed you, I ran multiple jobs here. And I added them to TensorBoard beforehand. And let me go to TensorBoard to show you the result of what I did previously. So for example, if I go to TensorBoard, you can see, you know, the top ones are all asynchronous job that I ran. And this one, the green one, is synchronous. As you can see, I started you know, adding, increasing the batch size. So I started with, for example, it was 4,000, and I went to 2 million, and also the default one, which was 6 million. As I increased the batch size, you know, the step per second went down, but I got a better results because I was adding more info into my model, so it could to calculate a better gradient, delta weight. And if I go down here, you can see the result that, you know, higher batch sizes has a better slope. But, you know, definitely there's speed, training is, there's a trade-off. Training speed is lower with them. So, for example, if you look at this one, the 6 million one, which is and I ran them for I think 1 or 2 hours, these ones, but the green one I ran it for day. For example, you can see this dark blue is the 6 million, and that's the default hyperparameter sets on T2T. So, you know, I started with really low batch size and went to the default number, and you can see the default number that is on T2T gave me, you know, a good loss function, but the speed was a little slow. And as you can see, the synchronous one was the best one. It was better than asynchronous. And when I talked to Ryan Sapasi, it seems that, you know, on T2T, for example, transformer model, synchronous is outperforming the asynchronous sometimes. So I just left the synchronous one to run, and as you can see, you know, it converged, and we got a good loss function here. So that was my presentation, Malo, about Tensor2Tensor, distributed deep learning. Because I'm doing a little bit of, you know, hyper tuning by changing batch size to see the results. Hopefully you like this presentation.
Awesome. I didn't see a lot of questions during the chat during the session, so I think we can just end it here. What I just want to say is we're organizing a bunch of those sessions. Next time we have Juicy Kalgren from GavaGuy. He's a PhD in linguistics from computational linguistics from Stockholm University, and is also a professor at KTH in Sweden. He's been a visiting scholar in Stanford, and he will talk to us about learning essential lexicon from streaming text data. So I hope to see you there. Thank you.